Okay, let's take a look at this problem. Things are getting a little more complicated here, or more fun, depends on how you like to look at it. You are on an ocean liner that is going eastward at 12 meters per second, and you run southward at 3.6 meters per second. Find the magnitude and direction of your resulting velocity. So right away we know we need to find two things: the magnitude, or the displacement, and the direction. So don't overthink it. Try to think about this simply. Draw a ship, draw the directions, let's try to think where it's going. There are a number of ways you can draw it, but we're going to end up with a similar shape. So it goes 12 meters per second east, and then you run southward at 3.6 meters per second. So we end up with a right angle triangle. Let's take a look at this. And if you think about it, this is the angle. I made a mistake and thought this was the angle, but actually this is the angle. And we can start to see some trigonometry and things we have to know. So if this is the right angle, we know that this is the hypotenuse, this is the adjacent angle, and if this is the angle, then this is going to be the opposite angle. So right away you may be starting to think, wow, we have the adjacent and the opposite, so we're going to be able to use tangent to find out the angle we're going. So let's take it step by step. In order to find the magnitude, we need to use the Pythagoras theorem, or vector addition, and we do this calculation. As you can see, we come out to find that the distance is the square root of 156.6.9, and then using your calculator, I'm assuming you have a scientific calculator, you'll find out that it's 12.5 meters per second. And for the direction, we need to look at the tangent, and as I said up above, you have the adjacent and you have the opposite. I asked a question here, why is 12 meters per second the opposite? That was wrong. 12 meters per second is not the opposite, it's the adjacent side. It's good to show you all my mistakes, and as I've said, I'm making these videos to show myself these mistakes so I don't make them again, but I hope you can benefit from them also. You can see also that I had these the wrong way around, and that's why I got the wrong answer. I need to have the opposite over the adjacent. So let's look again. Here is the opposite and here is the adjacent, so opposite needs to be on the top. And then with the calculator we find that it comes out to 0.3, and then using your calculator you perform the negative 1 tangent function, and you can find that it comes out to 17 degrees. So we know that we are going 17 degrees south of east, and the magnitude is 12.5 meters per second, meaning that that is our displacement from the place that we started. Just like to go over to some rules. The two vectors are at right angles to each other. Notice this, and then you'll know that we need to use this Pythagoras theorem, and that the magnitude of the total velocity is the hypotenuse of the triangle. Again, we can see this is the right angle, so the hypotenuse is opposite the right angle. And saying it again one more time, as Barron's has kindly shown us, for two velocities at right angles to each other, the vector sum is the hypotenuse of a triangle. Therefore, the velocity is the square root of 3.6 squared plus 12.0 squared, which equals 12.5 meters per second. And the direction will be south of east at an angle whose tangent is 17 degrees south of east. Thank you very much.